from Algebra 2, do you remember seeing arcsine, arccosine, arctangent? Okay, and those are the same as like an inverse sine. Okay. So we use those interchangeably. So these are not reciprocals, these are inverses. And what I'm really just trying to point out here on the first slide, it doesn't have a whole heck of a lot of information, but it's just the idea of an original function and then its inverse function. Remember way back in semester 1, chapter 1, to find an inverse, you switch x and y, or you can think about like your inputs and your outputs. Okay. And I just relabeled my x and y's because when I think about trig, I think about whether I have an angle or I have a ratio. So in the original, you input an angle and you get out a ratio. And then in the inverse trig function, those things are swapped, right? You input the ratio and you're trying to find the angle. So it's kind of like the questions that we were doing in the warm-up, but there's going to be a big difference today. The warm-up questions, I gave you that equation like cosecant of theta equals undefined. And then I said theta could be anywhere around the unit circle from 0 to 360. Okay, those rules change when we look at it through the lens of an inverse trig function. The other important thing that you just want to keep in the back of your mind is that we're going to make this a rule that will kind of mess some of us up. But the reason for the rule is so that it's actually a function. Okay, this inverse work that we're doing. And a function will mean every input has only one output. And when we're thinking about that in the inverse down here, every ratio that I give you will give me exactly one angle. And we already know from that warm-up problem, like there's lots of angles that could have a cosecant that's undefined. Around the unit circle, they were 0 and 180 degrees. But we could even just keep going around, 360 and so on and so on. Okay. So we're going to have to address that issue so that you all give me the same angle output. So what we're going to do on the next slide, this is the part that is like missing for you guys because you haven't done the graphs yet. So I'm going to do like a little bit of an investigation. I'm going to show you some graphs on Desmos just so you kind of understand what's actually happening with these trig ratios. So you're really going to want to make sure you get the last two columns into your notes. You're going to need the inverse sine, the inverse cosine, and the inverse tangent. And you're going to need to know the domain and range for each of those. Okay, so if you want to copy down a table, you want to definitely have those in your notes. I'll talk about domain and range for the others, but you'll know those eventually when you do the graphs next week. So to me, I don't expect you to know those for sine, cosine, and tangent yet. Okay, so I'm going to pull over my Desmos graph. And I'll go back to this slide here in just a minute. I already have like all my equations loaded into Desmos. And you don't have to draw all these pictures down. It's better if you just kind of look and try to make sense of it. Okay, here is the graph of y equals sine x. So if you haven't taken Algebra 3, you're like, whoa, cool, a wave, right? If you've taken Algebra 3, you've seen this graph before. Okay, we'll graph these next week. We call them cyclical graphs. They just sort of repeat themselves. The wave just goes up and down over and over again. And if we were talking about domain and range, do you agree that this graph just seems to be going left and right forever? So domain would be all real numbers. But the range for my graph is restricted by the height of my wave. So the range is -1 to 1. So I'm going to fill that in over here. The original graph has a -infinity to infinity domain. And the range would be -1 to 1. Now, normally when you do an inverse function, right, the domain and the range just flip. which would mean our domain would be -1 to 1, and our range would be -infinity to infinity. But what that would look like on the graph, so on my next one I just switched x and y. Do you see that dotted blue line? Okay, that's like reflected over the line y equals x. I'm going to get rid of the sine x. It's now like a vertical wave. Okay, it goes back and forth. And we can see the domain is -1 to 1, right? It's like stuck in between these like left and right waves. Okay? And the range is -infinity to infinity. It's going up and down forever. But the problem with this graph is this is not function. It does not pass the vertical line test. The wave that was the sine graph doesn't pass the horizontal line test, which tells us that our inverse is a function. So what this means, if I said to the class, I said, give me an angle like the inverse sine whose ratio was 0, that's our input, that's our x, you could give me this point right here at 0, so 0 angle. But you could also give me this point right here where it crosses because x is still 0. So you could tell me pi, or you could tell me 2 pi. And there's infinitely many answers where it would cross 0 for that x. So mathematicians and people using inverse trig function, which would be you guys, agreed to use one part of that graph. So it's a little bit hard to see. I'll get rid of the whole wave here in just a second. But there's this red part right here. We agreed to just use this one section because this one section will pass the vertical line test. It won't have the other part of the wave. So I'll get rid of it. We're just going to use that little branch. Okay, cut it off so that it's a function. Okay, now watch my cursor when I pull points on here. You can see like the different points that are allowed. Okay, this last point that works, see if I can get down there, is -1, -pi halves. And if I follow it up here, this last point that works is 1 positive pi halves. So for my x's, it ranges from -1 to 1. That would be my domain for my inverse. But my y's are restricted. Instead of -infinity to infinity, the lowest one was, sorry, it's weird when I get down here, -pi halves. And the highest angle I'm allowed to answer is positive pi halves. So make sure you have this in your notes for inverse sine. Domain is -1 to 1. And range is -pi halves to positive pi halves. Okay. So this is where things get weird. You're now not always going to answer angles from the unit circle if it looks like arc sine or inverse sine. You're going to give me answers in quadrant 1 or quadrant 2. You can give me pi halves, pi thirds, pi fourths, pi sixths, or 0 there in quadrant 1. But for all of these angles down here in quadrant 4, they have to be -pi halves to 0. And so you would give me -pi halves, -pi thirds, -pi fourths, -pi sixths. Those are the coterminal angles to 11 pi over 6, 7 pi over 4, and 5 pi over 3. But you're not allowed to answer those angles from the unit circle. So that's kind of weird. It's different now. But mathematicians, remember, mathematicians and we have agreed to use that one tiny branch. We're all going to use the same section of that branch for inverse sine. Okay, well, cosine graph is going to look very similar to the sine. I'll show it here to you in just a minute. So it has the same domain and range. Okay, -infinity to infinity and -1 to 1 for the original, which I don't expect you to know right now because we haven't graphed them yet. But I'm going to show you that here's cosine. Oh, it's just another wave. And with an untrained eye, if you haven't studied the trig ratios, you might think it's the same as sine, but they're actually different waves, just shifted of each other. Okay, so we'll talk more about that next week. But it has the same domain and range. Okay. So obviously, we have the same issue when we do the inverse, right? It doesn't pass the vertical line test. So mathematicians and we all agreed to use the same little section of that blue curve so that we'll all give the same answers when answering an inverse cosine or an arc cosine. Okay, and that little section that we agreed to changes. Okay, get rid of the blue part. It's this little section right here. So again, I'm going to follow it over to the highest and the lowest points. Okay, that high point is -1 pi. And the low point is 1, 0. So our domain for the inverse, the x's, is the same, right? -1 to 1. But the output, the y range, is different. Instead of negative pi halves to positive pi halves, it's 0 to pi. Okay, so make sure you get that in your notes. This is super important. -1 to 1, 0 to pi. Which means if I'm thinking about my picture, I'm allowed to answer cosines from 0 to pi in quadrants 1 and quadrant 2. So here's 0, here's pi halves. And for each of these, I get to use the angles on the unit circle. So like over here, I can answer 2 pi thirds, 3 pi fourths, 5 pi sixths. Those are fine. Now, you can kind of reason why cosine had to change a little bit. We can't use the same 2 quadrants for cosine that we did for sine, because in quadrants 1 and 4, cosine is always positive. So we wouldn't get any of those negative ratios. So then we agreed to use quadrant 1 and 2, because cosine is positive in quadrant 1 and negative in quadrant 2. Okay, the last one, kind of interesting for those of you who haven't graphed a trig ratio yet. Here's what the graph of tangent looks like. You might be expecting a wave, but you're going to be disappointed. Okay, tangent sort of looks like the same graph, like almost like a cubic function repeated multiple times. But the issue with tangent is, remember on the y-axis, at the vertical axis, tangent is undefined. So you get all these, there's really asymptotes right there. So all these breaks in your graph. Well, if you reflect that over the line y equals x, then those become horizontal. Okay. So you get these like sideways graphs, kind of like a cube root function, I guess it looks like. But it's different because it's really restricted. There's now like a horizontal asymptote above and below each of these branches. Okay. And then, of course, we decide to all use one of them. So I think we would probably feel comfortable with the fact that we're just going to use that one right in the middle, right, that goes through the origin. That's going to be our inverse tangent.
Is that equation still y equals tan, like the inverse tangent x, even though we're using the graph of x equals tangent y?
Well, yeah. So like we would solve for y, and we would have to inverse tangent both sides. So it is y equals tangent.
Okay.
Inverse tangent.
So like in my notes, should I write down y equals tangent x or x equals tangent y for the original graph?
Y equals tangent x is the original. X equals tangent y is the inverse, but it's not a function. And then this one, we're going to say is the function one.
Okay.
Okay, so notice for domain for tangent, inverse will be all real numbers. It goes left, it goes right, it goes everywhere. So domain for inverse tangent is going to be all real numbers. The range, like I said, you can't see it, but there technically are horizontal asymptotes. It looks like it's going to be at -1.57 and positive 1.57. That is positive and negative pi halves. So that's our range again. Okay. So we'll go back to that other slide. Domain is going to be -infinity to infinity. And the range is negative pi halves to positive pi halves. Now, technically, I think the book will use parentheses around that range because the pi halves and negative pi halves have undefined tangents. I wouldn't be too picky about that right now, whether you're using parentheses or brackets. Okay, if you see something that asks about undefined tangent, you know it's the pi halves angle. I'm not going to say a whole lot over here about the original tangent other than its range was negative infinity to infinity. But we'll talk about domain in notes 4.6 because that has that whole issue of every pi units, it gets cut off by a vertical asymptote. So we'll discuss later. But the nice thing about inverse tangent is its range is really the same as sine. So you're getting sort of the same picture. It's really only cosine that is different. So you have to do the same thing for sine and tangent. Don't answer in quadrant 4 those angles from the unit circle, 5 pi thirds, 7 pi fourths, 11 pi sixths. You answer negative pi thirds, negative pi fourths, negative pi sixths. Okay, first, I want to make sure your calculator is in working order for inverses. So this will be very short. Evaluate with a calculator. And the default for us as we progress in math is going to be radians. So please put your calculator in radian mode. Make sure you can get these ratios. Okay. If it says arc tangent, you're doing second tangent, so inverse tangent. You finally get to use the second button. Anybody do arc cosine yet? Error. What kind of error? Domain error. So if you go back and you look at the notes we just took, the domain for arc cosine or inverse cosine is negative 1 to 1. There is no angle that has a cosine of 2. You can have a secant of 2, but you won't have a cosine of 2. So that's not possible. Raise your hand if you're not getting those values, and I will come take a peek at your calculator. Did you put it in radian modes? That is negative 0.19. You wrote something entirely different. Okay, so everybody's calculator is in working order. If you want to match the answers in the back of the book, you need to have your calculator in radians. The go-to for this is radian mode. Okay. All right, now put your calculators away. Okay, here's where things are starting to get real for us if we don't really know our unit circle. You're going to feel overwhelmed, and I'm going to tell you this. You need to start practicing that unit circle. You need to know your coordinates for your angles. You have to know sine is y, cosine is x, and it's helpful if you know your tangents right off the bat. Okay, think about how this is going to work differently than what I was asking you to do in the warm-up. In the warm-up, I would have set up a problem that said the cosine of theta is equal to negative square root 2 over 2, and I would ask you to give me all the thetas from 0 to 360. Now I'm using the inverse cosine, arc cosine, of negative square root 2 over 2. So you're thinking about an inverse cosine happens in quadrants 1 or 2, right? I always picture my half moons for my ranges. If the ratio was negative, would that be in quadrant 1 or quadrant 2? You'll have to be in quadrant 2. Okay. So now you have to think about what are those angles in quadrant 2? 2 pi over 3, 3 pi over 4, 5 pi over 6. That which one of those would have a arc cosine of negative square root 2 over 2? 3 pi over 4. That's the only answer that's acceptable. You are not allowed to tell me 5 pi over 4. 5 pi over 4 is outside of the range of cosine. Cosine is 0 to pi. 5 pi over 4 is bigger than that. So you can't just use your unit circle. You have to be within the range that we wrote on the previous slide. Okay. All right, arc sine of negative square root 3 over 2. Okay, I'm picturing arc sines. Arc sines happen in quadrants 1 and 4. I always picture my half moon. Since the ratio is negative, would I be in quadrant 1 or quadrant 4 for that sine? I would be in quadrant 4, down there. And remember, be careful when you're doing inverse sine. These angles are not from the unit circle anymore. We do not answer 11 pi 6, 7 pi 4ths, and 5 pi thirds. You change them to be negative angles. Negative pi 6, negative pi 4ths, negative pi thirds. They're the coterminals, right? Just subtract 2 pi from all those angles. This is negative pi thirds. Negative pi thirds is the only acceptable answer. And the default is to give it in radians. I would say practice in radians. Okay. But that's the only okay answer. You can't tell me 5 pi over thirds. You can't tell me 4 pi over thirds. Because it's an inverse sine, it has to be between negative pi halves and positive pi halves.
I guess I'm still confused at why we can't just say it's 5 pi over 3.
Because we all agreed as mathematicians, and really the mathematicians agreed for you, and I told you you would agree to them. We all agreed to give answers in this range.
Oh, okay.
So like, because we want it to be a function, and in a function every input would have exactly one output. But if I don't put that restriction on the range, you're right. You could answer 5 pi thirds. Or you could answer 4 pi thirds. Or you could answer 11 pi thirds. Like they all have signs that are negative square root 3 over 2. But we all want to get in an inverse sign the same answer. So it has to be negative pi thirds. Okay? You have a set of cards at your desks for your pods. I'm going to give you 3 minutes. It's going to be short. It's going to be fast. You're going to go through as many of those as you can. Okay? Call me over if your group is arguing about something. Or if you have somebody who like super needs some help, call me over. I would write a few of these down in your notes as extra examples. Right, so you know how it works. Does every group have a set of cards?
These?
Yeah. Answers on the back, so you can check it. And that way you can call me over if you have any trouble.
I can't remember.
This one's tough when you start with this one. So just remember, in the inverse, this is a ratio. So you're saying what angle has a tangent of 0 within
But
the
it's
acceptable.
0.
On that one. Oh,
Saying the tangent is -1. So what angle has a tangent of 1?
So negative
You should know tangents. 1 square root 3 over 3, 1 square root 3. So it's the pi over 4 angle in quadrant 1.
Sine.
Because it's negative.
Why is it over 6?
You doing okay? Do
Let's do it.
you have something you need me to clarify?
I get that, but I thought, I don't know if the 1 over 6 was
So like right
yeah. Pi over pi. That's
No, like overthinking it. I know it's weird to get answers to that. No, it's not like circling up and now you can answer that. But it's like if you want to say like
the second root.
you want to say 5 over 3.
And it has.
Yeah.
They match.
You can't use
it.
Yeah.
How you guys doing? You need any clarifications? Yeah. You guys doing okay up here? Any of them that you want to talk about?
0, would it should be 0?
B.
Because it can't
Yeah.
be too high.
Right. Yeah. Because it's got to be between negative pi halves and positive pi halves. Okay, So we're saying this is the ratio, right?
Yeah.
So we're saying what angle has a tangent of negative 1? But you really probably know the tangent of quadrant.
No, it's
So
not.
what angle
The
is
one at the top.
Yeah. 45.
It's 2 pi over 2 pi. Yes. But does that say the range?
Yeah, because the range is 0 to pi.
You just do y over x.
I didn't know that.
Okay, our 3 minutes goes fast and is up. So these are the 6 problems that were out there. Are there any that you want to do and talk about?
Tan and negative 1.
Okay, yeah, I've had a few groups ask about inverse tangent of negative 1, so let's look at that. Okay, remember, if I'm doing inverse tangent, I'm instantly going to think about what that acceptable range looks like. So it's the same as sine. Now, one of these quadrants for all of these like half moons, I call them, is a positive, and one is where the ratios are negative. Since your ratio is negative, you know your answer is going to be one of those angles in the bottom 4th quadrant, okay? So remember, when you're doing inverse sine and inverse tangent, you have to answer those angles from negative pi halves to 0. So you can say negative pi halves, negative pi thirds, negative pi fourths, negative pi sixths, 0. You don't use the angles from the unit circle. You use their coterminals that are negative. I then don't really, I don't know my tangents that are negative, but I have memorized my tangents that are positive. So what angle in quadrant 1 has a tangent of 1? Pi over 4, because y and x are the same value, square root 2 over 2, square root 2 over 2. So then it's pi over 4 in quadrant 1, it's just the negative of that in quadrant 4. So that's going to be negative pi over 4. You cannot answer 7 pi over 4 because that's not between negative pi halves and pi halves. The arc sine of 2. So you're saying what angle, because you're answering the angle, this is the ratio, right? What angle and arc sine would happen in the same half moon as arc tangent? What angle from negative pi halves to positive pi halves has a sine, or think about a y coordinate of 2? On the unit circle? Nobody, because then you'd have a radius of 2, right? So this one is not possible. 2 is outside of the domain negative 1 to 1. If I ask you to do that with a calculator, you would have to be able to know the sine or cosine on the unit circle. And if it isn't on the unit circle, then it's not possible without a calculator. Any others that you want to talk about? Arc tangent of 0. This one can get confusing because you might start to read that as an angle instead of a ratio, because it just looks like a number. So remember, it's saying what angle has a ratio of 0, and the acceptable answers for arc tangent are in quadrants 1 and 4. Okay. I would just think about quadrant 1. I should know my tangents. So what angle in quadrant 1 has a tangent of 0? Y over x. 0. Because that's 1, 0, 0 over 1, and 0. And 0 is between negative pi halves and pi halves, so 0 is the correct answer. You cannot answer 2 pi, because that's outside the range.
Did you do the inverse of cosine?
Inverse cosine of negative 1/2. Okay, so we haven't done a cosine one yet here. Okay, inverse cosine of negative 1/2. Remember, now I choose on the half moon quadrants 1 or quadrant 2. Since the cosine is negative, I know my answer is coming from quadrant 2. And you actually use the angles from the unit circle on this one. 2 pi thirds, 3 pi fourths, 5 pi sixths. Which one of those has a cosine of negative 1/2? 2 pi thirds. That's your answer. 2 pi thirds is between 0 and pi, which is acceptable. Okay, you'll get better at this as you practice them. But the thing that you need to keep in mind is you have to stick to these rules. Okay? Remember that at the very beginning I double underlined the word function. And that means that everybody in the room has to give the same one angle. And so in order for us to do that, you have to stick within the range that we said. Otherwise, we can get different angle measures. All right, moving along, and you'll get to practice these ideas again. Sometimes we put regular trig functions with inverse trig functions. For fun. How about that? Well, I mean, at some point for solving. At some point, Katie, for solving, but for fun today. Okay, so we're going to a calculator. Okay, remember that inverses generally undo stuff, right? So a lot of times people might jump the gun and say like, well, wouldn't an arc cosine undo the cosine and the answer would be 4 pi over 3? Like that would be great. Except for that 4 pi over 3 isn't an acceptable answer to arc cosine. Remember, everybody has to give the same angle, and arc cosine happens from 0 to pi, and 4 pi over 3 is outside of that range. So what I would say is if you see a problem like this on the homework, just work inside out. Okay. What is the cosine of 4 pi over 3? Think about your unit circle. Cosine of 4 pi over 3. X coordinate on the unit circle. Using my hand trick, pi over 3, cosine is 1, and it's in quadrant 3, so it'll be negative 1/2. So I'm really doing the arc cosine and negative 1/2. And I think we actually did that one with stone. Right? We're thinking about the acceptable answers from 0 to pi, and that was 2 pi over 3. I mean, hint, hint, it's part of the pi over 3 family, right? But it can't be 4 pi over 3 because that's not in the acceptable range. Okay. All right, sine of arc sine of pi. Arc sine of pi. What angle from negative pi halves to pi halves has a sine of pi? There isn't one. That would mean that the y-coordinate was pi or the y-coordinate was 3.14. We don't have any coordinates that have pi in them, right? That's really like an angle. Okay, not possible. Can't do it. So again, that old thing where you would say like, oh, just cancel them out and say my answer is pi. Well, no, you really can't do the arc sine of pi. So you want to work inside out. Okay, you try thinking about this one. The inverse sine of the sine of 7 pi over 4.
Is saying sine to the negative 1, is that the same thing as saying arc sine?
Arc sine and inverse sine are the same thing, yes. Anytime you see that notation with the negative 1, it's calling it an inverse. Okay, work from the inside out. What is the sine of 7 pi over 4? Negative square root 2 over 2. So now you answer what angle from negative pi halves to positive pi halves has a sine of negative square root 2 over 2? That is? Negative pi over 4. Excellent. So again, you can't just cancel these out because then you will get 7 pi over 4, which isn't an acceptable answer to inverse sine. So you have to give the answer that's in the acceptable range. It's kind of weird. Okay. I'm going to do 2 more examples. They're a little bit different. I can also mix up different arcsines, tangents, etc. And my ratios don't even have to be on the unit circle, like 3/5. You don't know any cosines that are 3/5. You don't need a calculator. You just draw a picture. Draw a picture. Okay. If you were doing an arc cosine of 3/5, your option would be quadrant 1 or quadrant 2, right? Since this ratio 3/5 is positive, you must be in quadrant 1. So you draw a triangle, part of a bow tie, in quadrant 1. Angle always happens at the origin, and label it so that its cosine, x over r, would be 3/5. Right? 3, radius is always positive. Could you find the missing side? It is 4. That's a Pythagorean triple, right? When the hypotenuse is 5. And now can you do the tangent of that angle without even knowing what the angle is? Yeah, 4 over 3. Since it's in quadrant 1, all the ratios should end up being positive. Cosine of arcsine of negative 2/3. Well, if it was arcsine, I would be in quadrants 1 or 4. Since it's a negative ratio, I'm automatically in quadrant 4. Excellent. Draw a triangle that's part of a bow tie. And this would be my y over r. Remember, r is always positive. So 3 has to be positive. Y has to be negative, which makes sense in the picture. I'm going down. You would solve Pythagorean theorem, what? 9 minus 4 is 5, square root 5. And because I'm going to the right, it's positive. So the cosine would be square root 5 over 3. So if you see this mix and then all of a sudden you're like, that's not on the unit circle, you should draw a picture. Okay. You do have a homework assignment. To wrap things up today, we've got about 3 minutes. I want you guys to try and answer these 6 questions. On this little strip of paper. Remember, we had to manufacture a rule about range so that every single one of us would give the same answer for an inverse. So we chose a particular section of graph.